Hey guys, in this video, I'm going to show you how to find the point of intersection. Okay, so generally speaking, there are two ways to find the point of intersection. You can find it algebraically or you can find it graphically. But essentially, finding the point of intersection requires you to solve two equations simultaneously. Okay, let's have a look at this question over here. So it says, find the point of intersection between the two lines. So if we're going to solve this algebraically, what we need to do is basically solve them using simultaneous equations. So that's what we're going to do. So if you recall with simultaneous equations, there are two ways to go about this. You can use elimination or substitution. So in this instance, I think I'm just going to go with elimination. So that requires me to ensure that whatever variable I want to eliminate, it has the same coefficient in both the equations. So let's just say that I want to eliminate the variable of y. I need to make sure that their coefficients are the same. So that means I'm going to transform them both to have the coefficient of 6. So in order to do that, I need to times equation 1 by 2. So that gives me 4x minus 6y minus 6 equals 0. Giving me a new equation. And then I need to multiply equation 2 by a factor of 3. So that gives me 15x minus 6y minus 39 equals 0. So now that my coefficients of y are the same, I can essentially eliminate them by subtracting these two equations. Because it's a minus 6 and a minus 6, in order for me to get 0, I need to subtract them. So I do equation 3 minus equation 4. So 4x minus 15x is minus 11x. Minus 6y minus 6y is 0. Minus 6 minus 39 is positive 33. And obviously 0 minus 0 is 0. Solving for x, I'm going to subtract 33 from both sides. Then I'm going to divide by negative 11. I get a positive 3. That's my x value there. Solving for the y value now, I'm going to sub x equals 3 into any equation. Let's sub it into equation 1. So if you recall equation 1, it was 2x minus 3y minus 3 equals 0. So we're going to sub x equals 3 into this equation. So we get 2 lots of 3 minus 3y minus 3 equals 0. Now we just simply solve for y. 6 minus 3 is 3. Moving a positive 3 to the other side. And then dividing both sides by negative 3, I get y equals 1. And those are my two solutions. So x equals 3 and y equals 1. So the actual point, right, the point that they're asking for is going to have an x value of 3 and a y value of 1. So that is the answer to the question. So that's how you do it when you solve it algebraically. But you can also solve this graphically. So in order to do that, we need to draw these on a Cartesian plane. So taking the first equation here, we have 2x minus 3y minus 3 equals 0. So this is a straight line. The best way that I like to draw straight lines is finding the x and the y-intercept. So I'm going to first start by finding the y-intercept. So that's when x equals 0. So I sub x equals 0 into the equation. I get 2 lots of 0 minus 3y minus 3 equals 0. Now I solve for y. So 0 minus 3y minus 3 equals 0 minus 3y equals 3. And then y equals negative 1. So that's the y-intercept is negative 1. Now we have to find the x-intercept. The x-intercept is when y equals 0. So I sub 0 into y, so we get 2x minus 3 lots of 0 minus 3 equals 0. And then we solve for x. So we get 2x minus 0 minus 3. We get 2x equals 3, moving that to the other side. And we divide both sides by 2, we get 3 over 2. So the x-intercept is 3 over 2. So now we can actually draw the function. So a y-intercept of negative 1 is somewhere down here. And an x-intercept of 3 on 2 is like 1.5. So if I say that's 1 and that's 2, 1.5 would be in between. So joining those two dots together, we get a straight line. So that's the first straight line. Now we have to draw the second one. So we're going to do it in the same fashion. So this is our second equation. We're going to do the same thing. We're going to find the y-intercept and the x-intercept. So for the y-intercept, that's when x equals 0. So we sub 0 into this equation. So 5 times 0 minus 2y minus 13 equals 0. We simplify this and solve for y. So moving 13 to the other side, dividing by negative 2, we get negative 13 on 2. So that's our y-intercept. Now we find the x-intercept. So that is when y equals 0. So we're going to sub 0 into y, we get 5x minus 2 lots of 0 minus 13 equals 0. Then we're going to move 13 over to the other side, so we get 5x equals 13. Divide both sides by 5, we get 13 over 5, and that's our x-intercept, 13 over 5. Okay, so now let's draw this second function. I'm going to use a different color. So we have an x-intercept of 13 over 5. Now 13 over 5 is 2.6. If that's about 3 there, say, 2.6 would just be over the halfway mark, so that would be the x-intercept there. And the y-intercept is negative 13 on 2, which is negative 6.5. So I'm going to have to extend this bottom portion over here. Negative 6.5 will be just on the tip there. And then we're going to join the x-intercept and the y-intercept to form our line. So just like so. And then looking at the graph, we can see that the point of intersection is right over here. So it's got an x value of 3. And if you draw it across to find the y value, we can approximate that to be about 1. So the point of intersection is 3, 1. And that lines up nicely with the solution that we solved algebraically. The only thing with solving for a point of intersection graphically is you really need to ensure that your graph is quite accurate. Otherwise, your numbers are not going to be, they're not going to be very precise. You know, it's going to be off. So if it's asking for the point of intersection and it hasn't specified how to find it, I would strongly recommend doing it algebraically. So that's basically how you find the point of intersection. We'll look at one more example. Okay, so with this question, we're asked to find the point of intersection or the points of intersection, and we have a straight line and a parabola. So we're going to do the same thing. We're going to solve this one graphically, and we are going to use simultaneous equations. So we have y equals x minus 1, and we have y equals x squared plus 4x plus 1. So the easiest way to solve this would be using the substitution method. That is because y is the subject of both of these equations. So what we can do is we can equate them to each other because they're both equal to y. So then we can say x minus 1 equals x squared plus 4x plus 1. And from there, we can solve for x. So I'm going to move the x minus 1 over to the right-hand side. So on the left-hand side, we're left with 0. On the right-hand side, we're left with x squared plus 4x plus 1 minus x plus 1. Simplifying this, we get 4x minus x is positive 3x. 1 plus 1 is 2. Solving for x, we are going to factorize, so 2 and 1 plus in both. So we get x equals negative 2 and x equals negative 1. So what you realize here is that you get two x values. And so that's how you know you're going to have two different points of intersection. So one of those points would have an x value of negative 2. The other will have an x value of negative 1. Now we just need to find their respective y values. So you take your first x value of negative 2, sub that into either of these equations to find the value of y. So I'm just going to sub them into equation 1, just because it's nice and simple. So I sub negative 2 into 1, I get y equals negative 2 minus 1, which is negative 3. So the y value that goes with that x value is negative 3. And then we do the same for x equals negative 1. So negative 1 minus 1 gives you minus 2. And that will be your second. So these are your points of intersection. So make sure whenever you find the point of intersection, you don't just leave your answer like this. Write it as a point, because that's what the marker is looking for. So make sure you just do that extra step, writing them as points like so, and you should be good to go.